All right, hi everybody. I'm Dr. Josh Bonde. I'm a co-founder of the Nevada Science Center and the director of the research department here. And it's going to be fun taking you through our new lab and showing you some of the projects we're working on.
And I'm Becky Hall. I'm also the other co-founder, and I am the director of education here. And we are looking forward to sharing some of our research projects that we got going on in our new lab that we have developed here in Henderson, Nevada.
All right.
So I'll let Josh start it off.
Well, Becky's grabbing the camera. We are located down here. Our brick and mortar is in the Water Street district in downtown Henderson. So we are a Nevada-centric research institution and educational institution. So all the projects we're going to show you are real fossil projects that we are working on currently. So this is real science that's happening right before your eyes. And all fossils were collected under permit from the Bureau of Land Management or the Nevada Division of State Parks. It's important to note that you can't pick up vertebrate fossils anywhere without a permit from the proper land management agency. So just so we get that out of the way, all these fossils were collected under permit. All right, so let's get into some of our cool projects. So here, this is a project from Esmeralda County, Nevada, so the far western part of the state, for those of you who haven't been around for too long, for some of those of you out of state. It just kind of looks like a big lump of rock, right? But if you take a closer look, this thing is upside down. There's a tooth here that's worn flat. There's a tooth here that the root is all that's left. And if you rotate around here, these are tusks that are coming out at you. So this is the upside down part of a four-tusked animal called a gomphothere. So gomphotheres were really successful elephant-like animals that lived up until the ice ages in South America. And this one in particular is about 14 million years old. And again, we excavated this thing over in a far western part of the state, right underneath Boundary Peak, which is actually the highest point within our state. And so just taking again a closer look, this is the hard palate. So if you put your tongue on the roof of your mouth, that would be the equivalent on this animal here. It's from a pygmy variety of this animal, which is kind of weird. So this is our projects. From the same area, we have from another gomphothere skull, this little round thing that looks kind of like a fat grain of rice is actually a fossilized maggot. So it's really rare to fossilize things that are kind of squishy and gross like that. But for some reason, these things were preserved in this unit. And so we're working on trying to figure out how we preserve squishy things and what that tells us about the environment these animals lived in. Over here, again, from the same area, these are pieces of petrified wood. Within the petrified wood, you can kind of make out these little spheres and little blobs. So what these little spheres and little blobs are, these are fossilized seeds within the petrified wood. So how did the plant seeds get inside the tree that fossilized? This is a fossilized seed cache. And so if you think of a squirrel or a bird that hides their seeds during the summertime so they have food through the winter, that's what this is, except it got fossilized. So 14 million years ago in Western Nevada, a little squirrel left its seed cache and never actually got, to use it because it got buried and eventually fossilized. So that's kind of cool. We can see where rodents and birds were interacting with petrified wood, so we kind of get a sense of behavior from millions of years ago here in our state. And then just some other bones just kind of round out what this area of Nevada looked like. This is from a giant shoulder blade. So this is the part that would attach to your upper arm bone, probably from a big camel-like animal. Camels were really, really common during this period of time. This is the head to a femur. And so the part that goes into your hip bone, from something about the size of a medium-sized horse. A finger bone, probably from a weird carnivore-like animal. The carnivores running around during this period of time were things like giant saber-toothed cats, bear dogs, animals like that. So if we look over here, kind of rotating the camera, this is from rocks that come from a little bit closer to Reno. So here we have, these are about 12 million years old. So a little bit younger than the rocks I just showed you. This is the lower part of your upper arm bone, except rather than your arm bone, this is the upper arm bone to a camel. Here we have the elbow to something probably like a rhinoceros. So if you feel the bump on the back of your elbow, That's what this little knob is. So the term is called the olecranon process, if you want the scientific term for it. And then here near Fallon, Nevada, from the same formation as these, from an ancient lake, these are fossilized fish. So you can see the little backbones here, and you can kind of see the outline of the animal around here. So these died in a lake. If you've ever been around a reservoir or a lake in August, early September, like the time we just passed, and the lake turns green and mucky, when all that muck settles to the bottom of the lake, that's what these layers of white stuff here, and that's mined up in northern Nevada, and they use it as filters. It's called diatomaceous earth. A couple more of these little fishies. It's a good one. These are called stickleback fish. And here's one that's kind of fallen apart. So in addition to digging up big stuff that that are really obviously fossils, we also do smaller fossils. So this is a screen that we pass sediment through looking for small fossils. So if you look in this vial, all those little scraps in there are little bones that we can only find by looking into these screens. So here at the Science Center, we have a whole screen washing set up to look for little rodents, little dinosaurs, little lizards from all the various projects we're working on across the state. And to go way back in time, we also have projects that span all the way back into the Paleozoic era. So oftentimes I get asked, what's the oldest fossil that we work on? This is a trilobite. This one was found near Goldfield. So this is a little over 500 million years old. So over 500 million years of time preserved here in our state that we're working on and trying to interpret. So this one's about 530 million years old. This one from near Duckwater, Nevada, is about 320 million years old. You can see the shell, it's kind of coiled up, and you might be able to make out the zigzags there in the shell. So these are from animals that are called ammonites. Ammonites are related to the chambered nautilus, if you're familiar with that animal, or kind of coiled up squids with shells. So this is a 3D print that was made by our friend Bernard Means, who will be giving another virtual field trip on November 18th. So tune in for that. He talks all about 3D scanning and printing of fossils and artifacts. It should be pretty cool. So he printed this replica of an ammonite. So you can kind of see the shell here, the actual shell, versus the replica, the coiled up with the little squid thing sticking out of the shell. So all the way from 500 million years ago to about 10,000 years ago, also our friend Dr. Means at the Virginia Commonwealth University printed some Ice Age fossils for us. So a mastodon tooth versus a mammoth tooth. So you can see the difference in these teeth. So even though mastodons and mammoths looked a lot alike, lived during the same period of time, looked like elephants, they were kind of distant cousins, and we can tell by their teeth. And then Dr. Means also scanned a piece of giant ground sloth poop and printed that for us. So these things are so recent, their poop mummifies in some cases, and we get to 3D scan and print it and get the benefits of that. Dr. Means also scanned and printed this direwolf knuckle, one of only 2 direwolf bones ever known from the entire state of Nevada. This particular one was found on the new Ice Age Fossil State Park, which will also be the focus of an upcoming virtual field trip. All right, so with that, I'm going to hand the reins over to partner in crime, Becky Hall.
All right, so now we're going to move to the Cretaceous. So everyone's waiting for the dinosaurs, and this is where I'm going to take off. So here at this table is one of the research projects I am working on from the Valley of Fire State Park. It's a park right outside of Las Vegas, and I have a research collection permit to do my study there, and I am researching a site that has a new species of hadrosaurs. So what's a hadrosaur? I got a little guy right here to show you if you don't know. Their early cousins were called iguanodons. So many hadrosaurs had big crests. So you see those crests on hadrosaurs. This one didn't have a crest because those came later on when they became more abundant, but they were like the cows of the Cretaceous. They ate a lot of plants, and back in 100 million years ago in the Valley of Fire, There's a lot of rivers and ponds. So this dinosaur would have been cruising around, possibly fell in a river and passed away. So what we have here are a lot of backbones. So if you think of a huge dinosaur, they're gonna have a lot of backbones, more than we have today. So, and they come from different parts of the back. So you'd have some in the neck, some right in the back, and then all the way down to your tail. So this would have been some of your bigger back vertebrae or backbones. We got pieces here, and then we have some smaller ones like these ones would have been in their tail to help support their tails. So you can see one here, the process is coming up. And then we'd have even smaller ones that could have been in their neck and called cervical. So like here's one of those. So unfortunately, I can't just go up and go pick those out of the ground. They come in these big chunks of rock called float, and they're coming really hard sandstone. So if you're walking around a river today, you'd be walking in some sand or some gravel. Well, over 100 million years, that sand and gravel gets cemented together, and it looks like a rock. It is a rock, right? Sandstone. It feels like sandpaper, but I have to have my paleontologist eyes open to see the bones that lie inside the sandstone. So right here is a bone. I don't know if you can see that it looks a little bit different than the rock around it. It has a purplish tint to it, and you can actually see bone texture in it. So I have to use mechanical tools to remove all this very hard sandstone out to get the bone out. This dinosaur I've been working on for 2.5 years, almost 3 years, but we're almost done with it. And then once I'm completed with it, publish my paper, I'll be naming a new species of dinosaur right here in Nevada. So besides the dinosaurs that come out of Valley of Fire, we also have plants and other ones. So we have, I don't know if you can see this little plant leaf right here. So soon we'll be having our autumn leaves fall into the ground. So this was a pond that got covered in an ash layer. So this is all ash from 100 million years ago. Covered a pond, and it preserved the plants that were in this pond. So these were the plants that this big hadrosaur would have been munching on. We also have different petrified wood and other plants that would have been there too. How about teeth, right? So we find teeth too. Check out that tooth. That's a pretty big one. Got a couple more, whoops. Right, there's some in this chart. These are all from crocodiles. So just like today, they had crocodiles back then too, hanging around with the dinosaurs, and turtles. So these are all part of turtle shells. And once again, we're looking at the texture in those fossils, which help us determine if it's what it is. So it's a turtle. So here's another long bone from the Valley of Fire. This one is the most recent find. Earlier this year, we found this right before the pandemic hit. And so we don't know what it is yet, and we haven't done much research on it, but look how long it is. It's the size of my arm. It's pretty big. Let's see. Oh, here's another dinosaur tooth. So this is a lot different than this crocodile tooth, right? So this crocodile would have been a carnivore, a meat eater. Would have been good for tearing open that meat. This one, you can see it really flat. This is from a hadrosaur because they ate plants. So they would have hundreds of teeth in what is called a dental battery, and it would have been good for grinding up all that plant material in their mouths. So I'm going to pass it on to our next dinosaur site in Nevada. It's in central Nevada in Eureka. So we're going to be in the Valley of Fire on October 23rd, and then we're going to be in Eureka, Nevada, October 12th, where we have our dinosaur site that we still have to excavate.
All right, so for those of you who tune into our Eureka field trip, so you're going to see where, or at least the rocks where some of these other fossils came from. So like the Valley of Fire fossils, which are about 100 million years old, the Eureka fossils, also from the Cretaceous period of the age of dinosaurs, are a little bit older. So they're about older by about 5 to 10 million years. So these are a little bit older dinosaurs. But from this period of time in central Nevada, we got all sorts of interesting animals living alongside the dinosaurs. So this here is a fish scale. It's got kind of a weird little rhombohedral shape with a little notch on the side of it. Here's another one of the same type. The kind of the shiny part is the rhombohedral scale. These are from garfish. So if you want to Google what a garfish is, or if your parents or you are a fisher person, these are still around today. They're not nearly as common as they used to be, but these were cruising around the rivers of central Nevada about 110 million years ago. And snapping up these garfish were things like crocodiles. So just like we just saw crocodile fossils from Valley of Fire, these are all the little bumps. If you look at the back of a crocodile or an alligator and it looks all bumpy, that's because the skin is full of these little bones called osteoderms. And so it's kind of a chainmail of bone embedded in their skin. And so we see lots of these bones because they're really hard, really dense. They preserve really well in the fossil record. Here we have another crocodile bone. So this is a backbone to a crocodile. So really common animals. So if you figure the Earth is much warmer during this period of time, there's lots more water in central Nevada. So cruising along these waterways are going to be things like crocodiles and turtles. So this is a piece of turtle shell. So crocodiles and turtles are the most common animals that we find within this geological formation. But again, that just makes sense. If we have ponds and rivers, there's going to be turtles and crocodiles. So on to the dinosaurs. This is kind of a cool bone. So it just kind of looks like a rock, right? It's round, it's kind of weird. It's got some weird patterning. So backside, front side. But this bone actually tells us exactly who it came from. So the armored dinosaurs like Ankylosaurus had bones exactly like this embedded in their arms and legs to keep animals from biting them. So this is again called an osteoderm, just like crocodiles have, but this is a dinosaur osteoderm. And so this tells us that animals like Ankylosaurus 110 million years ago are stomping around Eureka, Nevada, or at least Eureka County, Northern Nye County. And then also we get some of these great big, this whole thing that also looks like a rock is all bone. So see that texture in here? It kind of looks grainy, kind of blobby. That's what bone texture looks like. So if you were to look at a cow bone today or look at a chicken bone, these same textures would be inside that. So a lot of times we get asked, how can you tell that's not a rock? Well, we're looking for patterns like that, which tells us something biological. So this is a big bone from a big animal. One of the cool things about this project up near Eureka, we have several sites where we're digging up fossils right now. We don't know who the animals are yet. We just know they're dinosaurs and we know they're really big. So that brings us to one of our ongoing digs that we're doing at the Nevada Science Center, and an active dig that we have near Eureka. It was a hot summer day and we're out there prospecting. So that's the process of going out there and walking around the right types of rocks, eyes on the ground like good geologists, good paleontologists, looking for bones. And we started seeing these little scraps of bone on the surface. And we started following those bones up the hill, little pieces of bone. We started following them up the hill until we didn't find any more. And then we dug a hole, and in that hole was this bone. So this bone was sticking out of the ground, a couple inches under the ground, and we were able to fit these pieces that we found down the hill onto it. When we find something like that as a paleontologist, it's really exciting because that tells us there's something big in the ground underneath it. So as we began to excavate, began digging around it, this thing quickly became bigger than our permit allowed for. So we had to apply through the Bureau of Land Management for permission to dig a big hole to dig up a dinosaur, which they granted us permission to do. So some of the bones that have come back from this new dinosaur site, great big round edges that should fit onto other bones. A big piece of either an arm bone or a jaw bone. We're still trying to figure that out. Kind of interesting looking. And just another piece of well-prepared bone. Becky was the one that prepared these fossils. She did an outstanding job on it because they're kind of fragmentary. And in some cases, you can actually see where there's the mineral calcite has gone in there and started growing great big minerals and broken the bone apart a little bit too. So no easy task, but she has the patience to do that. Now, these are some of the smaller bones that we've recovered. There's still a great big animal out there in the rocks. And so, like I just said from the outset, these are ongoing science projects being conducted under permit from land management agencies. So we don't know who this dinosaur is yet. And so it's our job over this coming fall, this coming summer, probably the next, go finish digging this thing up. And it's probably going to be another new Nevada dinosaur. So stay tuned to the Nevada Science Center. Hopefully we'll have some new news about this in the next couple of years about what type of dinosaur we went and found. And then just some couple other bones from other sites near Eureka. I think this is part of an upper arm bone. If you eat chicken wings, like I enjoy chicken wings, and you eat the drumette part of the chicken wing, and you look at the very top of that, that's the upper arm bone of the bird. Because dinosaurs are really closely related to birds, it kind of looks like that general shape. So that's what makes me think that this is part of an upper arm bone. So again, from another dinosaur that we don't know who it is yet. Some other fossils that we have found in the same area, these are snails. So some Cretaceous escargot. These would have been living in the same ponds and rivers that the crocodiles and the fish were. Some petrified wood. So we had trees growing along these rivers as well. And then, let's say a note about the techniques.
Oh yeah, sure.
Okay.
So you want to flip it around? All right, so Josh mentioned a couple things about preparing the fossils. So when they come to the lab, they don't look nice and half the time we can't even identify them because they're still stuck in rock or sediment. So we have mechanical tools and even small tools that help us remove the sediment or rock around. So some of these might look common. There's not a paleontologist store we go to. So I'm sure you guys might have seen this before, maybe even been scared of that. So dental pick, right? So the dentist usually uses this to clean your teeth. We can use it to precisely dig or chip away at sediment. So this is a common tool we use. Paint brushes. So we all seen those before. So there are paleo artists out there, but we're not them for sure. So we use these to dust off sediment or bone. So like in here in this rock, this one just started. So you see we still have a lot of rock here, but here in the middle, this is really hard. So the paintbrush isn't gonna do anything. But mechanical tools, we can remove all the sandstone to get the bone out. So other things we use, who has like a baby brother or sister, cousin, right? No, we're not doing dinosaur boogers here, but this can blow dirt away. So even some fossils are so fragile that you can't even touch them with a paintbrush. So this one just uses air to blow off the dirt. Tweezers and awl, so digging around. And if you're gonna be a good geologist, this is a very important part. So if you ever wanna send us a picture of your fossil, make sure you put a scale bar in it, right? So this is a little ruler, or even put a pencil. So when you're taking a picture of a fossil or something, you have no reference of how big it is, right? So I could zoom in and take a picture of something small that would take up the whole picture, or I can be way back and take a picture of an arm bone that this is this far big. So a scale bar is very important when you're taking a picture of your rocks, your fossils, and you can send them to us. So other things, Sharpies are a must. And we have, we use hammers out in the field, and we also have chisels. So chisels to take away the rock and sediment too. So these are all a few of our common tools that we can use to help us prepare the bones or excavate the bones when we're out in the field. So with that, that's our conclusion of our show and tell part, but we want to make sure that we answer some questions for you guys. And then if there's anything that you want to see again, we're more than happy to come back and look at those too.
That was an awesome presentation. So again, if anyone has questions for Josh or Becky regarding what they showed us today or about the Nevada Science Center, feel free to message them in the chat feature of Zoom here. If you want to learn more about the Nevada Science Center, please visit sciencecenternevada.org. We have some questions from some of the students. They wanted to know around how many fossils do you guys think you have right now at the Nevada Science Center?
I would say between all of our projects, we probably have around 250, 300 fossils. But that's everything from small little trilobites about the size of a nickel all the way up to the size of a golf pyramid.
Right, so all of our projects that we're working on at the Nevada Science Center are still ongoing research. So these are brand new projects that we're still working on. Once we're done preparing them, researching them, publishing papers on them, that's when they get to go to the museum where everyone else can see them.
We have a question from a teacher. She wants to know, can you tell the kids, how old do you have to be a paleontologist?
How old do you have to be? There's really no age limit. We've had people volunteer on our digs that have been 12 years old, or even a couple that were a little bit younger than that. All you need is an interest, an opportunity, and if you're ready, start reading books. I would say my professional career, though, didn't start until I was in college, but you can start being a paleontologist whenever the interest arises, and you can start digging up fossils.
Yeah, you can find fossils right here locally in Las Vegas. So if anyone's ever been up to Mount Charleston hiking or sledding, or you've been over to Frenchman Mountain, we have fossils there. So we can't collect, our citizens can't collect bones, like dinosaur bones, but you can collect shells, corals, which you'll find at Mount Charleston, and we'll be having a field trip next week, is it the 28th?
Yeah.
On Monday for Mount Charleston, and we'll be talking about some of those fossils. And then at Frenchman Mountains, we have trilobites. So just like Josh was saying earlier, these little critters that lived 500 million years ago at the bottom of the ocean, you can find those at Frenchman Mountain. So you can be a paleontologist at any age.
There you go. You heard it there first, folks. So we have a question from a student. They want to know, how long does it usually take to dig a complete theropod? If you could estimate that.
To dig a complete theropod. So number one, it depends on where it is. So if it's right next to a road, that's really helpful. Most of the time they're not. And the type of rock they're preserving. So if they're kind of like a mudstone, usually you can get one of those jacketed up within a summer. So we're talking about a couple months. There's been digs I'm aware of. I haven't dug up a complete theropod before, but people that I know of that have, you could talk multiple summers. So it might take 5 years to get a big complete theropod out of the ground. But if you find a complete one, it's definitely worth the effort.
And just remember, once you get it out of the ground, that's not when it's over. It's usually in a big jacket. There's a lot of rock and sediment, so it takes years and years. Just like I said, it's been taking me about 3 years to do this hadrosaur that's not even complete. So it takes a long time to prepare those fossils.
Which we do here.
Yeah, and it depends on the size of team you have. So you have to have a team of paleontologists and helpers to go out to get a full specimen out like that.
About how long would you say that you guys are at your jobs every day?
Every day? I would say any given day it's a normal work day, so we're here at least 8 hours in a day, and because it's kind of an unusual type of job, we're here weekends, we're here on holidays, so whenever, in addition to being a job, it's also a passion, so whenever we can do it, we can.
Yeah, and besides just being in the lab, we're also going out into the field. So we can spend a week out in the field and then come back. So it really depends on what kind of work we're doing. Are we excavating? Are we looking for fossils? Are we preparing them and researching them?
It's a good answer. So we'll answer a few more questions, and that brings me to another student's question. They want to know if they want to see some of these fossils at the Nevada Science Center. Once the quarantines and all that are over, are you guys going to be open for the public to come view some of these fossils?
So right now we're going to just do it. So we are a lab, so we're just going to be doing reservations or in advance. So email us, and then we can schedule an appointment where you can come down and see some of these fossils and see us work.
Yeah, these are all from public land, so everybody deserves a chance to come check them out.
And that brings me to my next question. A student wanted to know, are excavation sites, are they open to the public? Or are they closed, like a crime scene? How does that work?
Typically, our sites are closed sites because they are scientifically sensitive. There's been incidents, unfortunately, in the past where active dig sites have been vandalized. Either people not knowing any better and just being curious, or people wanting to do bad things, unfortunately. But so we do have to keep our active fossil digs private. In very limited scale, sometimes people can come out on tours, but we're not really offering that through the Science Center necessarily just yet. So long answer to your question is no, typically they're private.
Okay, and then we have some students want to know, have you guys found any fossils at Lake Mead by chance? Lake Mead area?
So I actually am doing a research project right now on Lake Mead. I'm working on Triassic trackways. So today we showed you a lot of bones, a lot of fossilized bones. The research project I'm working on at Lake Mead are Triassic tracks, so all that's left behind are footprints. I don't have those at my lab today. They are at Lake Mead, but that's going to be a new publication coming out later this year too. But yes, at Lake Mead, there's lots of different fossils out there too.
And I got this question quite a few times from the students. They wanted to know about that new dinosaur that you guys might help name. Do you guys have any ideas for the names?
So we nicknamed it the Pyrosaurus, so pyro meaning fire, so Valley of Fire, but no, there's not any determined names yet. If you have some suggestions, let us know.
All right, and I know that some of these classes and schools need to get off to lunch, so we're gonna end it with this. Do you guys have any advice for the students who are interested in studying paleontology or archaeology? What kind of things should pique their interest as far as going down that career path?
So the advice I always give to aspiring paleontologists or aspiring scientists in general is to read, read, read. So if you're interested in it, reading should be really easy. So go to your library or your school library and find lots of books you can read about it, websites. And then when you're old enough, find a local museum or a local science center and ask if you can volunteer. So oftentimes we have way more projects that we can work on. Oftentimes there's volunteer opportunities if you just ask to get some experience.
That, and not to be discouraged. You know, there's going to be hard classes that you have to take, or just maybe feeling, you know, that there isn't going to be a career opportunity. But paleontology has a very wide range of career opportunities. So you can be a researcher, a professor, an educator, a consultant. So there's a lot of different professions that you can do paleontology with. So it's not a one career path.
Right.
That is wonderful. Well, thank you guys very much for today's awesome event, everyone. We will have this video posted on the Nevada Science Center website. Thank you all for participating today. And Josh and Becky, is there anything else you want to tell us about the Nevada Science Center?
So we appreciate you attending this. We're just getting started, so we're a new nonprofit here in Nevada. So just, you know, check out our website, sciencecenternevada.org, and we'll have upcoming events as we grow too. Anything else?
Educational programs, research programs, programs for the public. So yeah, we're here as a resource to all the citizens of the state of Nevada and beyond.
Well said. Thank you guys very much, and we will see you next time.
All right, thank you.
Bye.